Hello, in this short little video we're going to talk about indicators. And so what is an indicator? It's the thing in your titration that changes color. And so these are dyes because they have a color and a really strong color at that. And they change color very noticeably over a narrow range of pH. And so in order to do this, your molecule is itself an acid or a base. Typically we use weak organic acids. And then when it loses or gains the H+, it causes some other structural rearrangement of the molecule, which then leads to it absorbing different colors than it did before, or in the case of phenolphthalein, going from clear to colorless. And so a good indicator is very intensely colored, so that you only have to add a small amount of it to solution to see what you're doing. You don't want this weak organic acid that is your indicator to affect your titration at all, because it's going to have its own Ka, etc., etc. So you want it to be in very low concentration. You also want the color change to only come from the acid-base properties of the molecule, so only from pH. So for example, you wouldn't want an indicator that interacted with your conjugate base or something like that, like chemically reacted with the other parts of your titration. You don't want that. You just want something that changes color based on pH. And so you can write an acid ionization equation for your indicator with the hydrogen on it. This is the acid form. Here's the conjugate base. And then somehow these are different colors. I just guessed random colors to make them look pretty. I don't know. So you can write a Ka for your indicator. This is Ka for indicator. All right. So your whole goal of doing a titration is that you want to find when the moles of acid are equal to the moles of base. So say you're titrating in sodium hydroxide, you have some acid, you want to know when you have equal moles of both. And that is your equivalence point. However, when you're doing the actual titration, you're going to stop when it changes color. And so this is known as the end point, because you stop. Now, ideally, you want these two to be the same, so that you stop doing the titration whenever it's actually at the equivalence point. And so when you're doing a weak acid strong base titration, at the equivalence point, you have the conjugate base still there. And so then your pH is going to be a little above pH 7. And so then you want to choose an indicator that changes color, maybe at pH 8 or 9. Conversely, if you're titrating a weak base, at the equivalence point, you'll have the conjugate acid left over and the pH will be acidic. So then you would want an indicator that changes color around pH 5 or 6, something like that. And so just here are some examples of indicators. Generally, there's a 2 order of magnitude range over which it will change color. And so this is what we're trying to say over here, that when one concentration is 10 times that of the other, then you'll have one color. When it's the other way around, you'll have the other color. And keep in mind, a 2 order of magnitude range is 2 pH units, because pH is a logarithmic scale in base 10, and so pH 7 and 9 is 2 orders of magnitude, a factor of 100. And so your indicator will change color, hopefully over less than 2 pH units. So the question we can ask you relating to indicators is basically which one would you use for a given titration? And so here's our example. We have nitrous acid with potassium hydroxide. So nitrous acid is a weak acid. Nitric acid, HNO3, is the strong one. Less oxygen's weak. So this is a weak acid titrated with a strong base, potassium hydroxide. So at the equivalence point, we're going to have a conjugate base left around, and that's going to make the solution basic. So our pH is going to be greater than 7, and so we want to choose indicators that change color around pH 8 or 9, something like that. And so cresol red or phenolphthalein are probably good choices for this titration. So that's what I have about indicators. Thanks for watching.